At the beginning, we need to adjust the initialization of the SID and VIC registers, as we only want one sprite, and we won't need the music. I created a helper program for loading. I copy the first line of the demo, which contains the data needed for loading, paste it into the loader program, and modify it to specify where the data ends. The helper program displays what it sets up for me. We don't need the SID registers, the two sprite pointers, or VIC plus 32 and 33, which set the screen and border colors. The SID and sprite pointers are gone, and now we just need to remove the screen and border colors. The space character might be helpful since its code is 32. At the end, the jumbled numbers show that I accidentally deleted one extra character. Now it's fine. I'll set the end of the data sequence, then copy it back and test. For now, there are multiple sprites on the screen, but I'll fix that later. However, the sprite's data is already visible at the top of the screen. I'll remove the Y coordinates of the other two sprites so they don't interfere. Okay, now we'll keep incrementing address 1024, which is the top left corner of the screen, to see how the sprite's image changes. Of course, this doesn't make much sense as it is, but this method can be used to create animations. First, I'll copy the line that writes the sprite data twice and modify part of one. The clear clears the entire screen, which causes heavy flickering, so we'll use home instead. Now it's fine. It animates the sprite nicely, even if the second phase isn't too pretty. Of course, we could also animate by changing the sprite pointer. In the next video, we'll see why this method is good and how much faster it is compared to using data lines.